What's going on, guys? Welcome back to this video. Today we're doing TryHackMe and we're gonna pick up where we left off in the last video. So security engineer track, and today we're going to start with network and system security domain. So here the first one we will tackle is secure network architecture. And in this room we're going to demonstrate some concepts that are commonly used when designing a secure network. So this room doesn't have labs. As you can see, we only have one demonstration or dynamic site, and the rest of the tasks are only questions and answers. So to start with, we're going to start with the first task, which is network segmentation. Now in the network segmentation, guys, the explanations are mostly done on the VLANs. So the concept of VLAN. So I'm not going to take you through the readings here, right? Because as you know, guys, you're watching the video because you don't want to go through the readings. So to complete this task, it's enough to understand the concept of VLANs. Let me show you guys an example. So this is from Google. You can see many examples on, just type VLANs here and you'll see many demonstrations. It's a very widely discussed subject in the networking arena. Okay, this example here. So the purpose of VLAN, guys, as you can see, is to separate networks and group them into logical maybe departments or specialties. For example, as you can see here, the first device here, the exhibit A 192.168.1.1/24. This is a network, and other network is 192.168.1.2. They are actually on the same network. So A and B are on the same network, right? And they're connected to these two ports. And then we have 2.1 and 2.2. They are completely on different network, okay? But all of them have, except this one, have the same gateway. Nonetheless, so we can call this a VLAN, and we can call this a different VLAN. So the purpose of VLAN is to separate networks, logically separating networks, so that later we can control the traffic flow between VLANs and the outside world, meaning the internet. And as you can see, guys, the switch is connected to the router, and there is something called the trunk port. So the purpose of the trunk port is to allow the communications between VLANs. So we said earlier that some VLANs are residing on totally different subnets, like disconnected subnets. So in order for these VLANs to communicate with each other, we need a router. The router will take on the mission of routing packets between different VLANs. Now we can call this HR VLAN, and we can call this maybe sales VLAN. So what happens here, let's say an attacker got access to a network on this VLAN. That attacker will only be able to infect computers in that VLAN, okay? Now, I know the router here will route packets between VLANs, but this will minimize the risk of a malware spreading to all the network as if they were on one network or one VLAN. So here we separate them into different VLANs, and the router will take the job of routing the traffic between VLANs, okay? So this is called network segmentation. And in this task here, as you can see here, these commands are executed on this switch. It is open virtual switch. As you can see, you can download it and practice commands on it. And as you can see, routing between VLANs. So these commands, you cannot memorize these commands, right? Because these commands are specific to these vendors or these type of routers and switches. And as you know, we have many brands, many vendors. So for now, you can just understand the concept, and maybe you take a note of these commands if you need them later, when you, if by chance you have an opportunity to set up this router at some workplace or some other place. All right, so we have these questions here. How many trunks are present in this configuration? So this configurations on the router and the switches. As you can see, we have for every port there are tags. So these tags are used to tag the VLAN itself. So these ports usually represent ports on the switch appliance or the switch hardware, right? And then as you can see, we have bridges BR3, bridges BR1, BR0. These represent the trunks. As we showed you guys earlier, you should have trunks here to allow the communications between different VLANs. So as you can see, we have 1, 2, 3, around 4 bridges, meaning we have 4 trunks. What is the VLAN tag ID for interface Ethernet 12? So interface Ethernet 12. This is Ethernet 12. Now port Ethernet 12 represents a physical port on the switch. So we set a tag for that physical port, tag equal 30, and interface is Ethernet 12. So the reason we set tags between for all physical ports on a switch is that we want to allow an effective recognition of these packets during the communication between VLANs. So that's why we set the tags, and the tag here is 30. So that's a very brief example or explanation on the concept of virtual local area networks. Now, virtual local area networks is very important subject if you are preparing for Cisco CCNA certificate, or even in Security Plus. CompTIA Security Plus VLANs are also discussed. So let's move on to the next task, Common Secure Network Architecture. So here we talk about the subject of zoning. So a network is divided into zones. So this is an example of zoning. As you can see, we can divide this network into different security zones. As you can see, the first zone is the internet. We call this the external or zero trust zone, because as you know, attackers come from this zone. And here we have the DMZ zone or demilitarized zone. So here we set all of the servers, workstations, endpoints that need to be exposed to the internet, meaning we need these workstations to receive traffic from the internet and send a response back, such as web server, email, proxy. Usually we place workstations or servers in this zone that need to communicate with the outside world, specifically as the role of servers, to act as a server. Here, this is the demilitarized zone, and this is the external zone. And we have internal zone. We call this the trusted zone. It includes the workstations and other servers that shouldn't be exposed to the internet. Meaning that if a packet was destined to the internal server on the internal zone, it will be dropped by the firewall, right? The internal servers here can only communicate with the workstations or with the demilitarized zone. They don't need to be exposed to the public internet. On the other hand, the user workstations can communicate with the outside world, meaning can communicate with the internet zone by sending and receiving packets. The firewall will take care of that by setting what's called the access control lists. And they talk about access control list in the next task. So as you can see, we explain all of these in one demonstration here. All right, the questions from the above table. What zone would a user connecting to a public server be in? It is the external. So user coming from the outside, connecting from the internet are considered in the external or zero trust zone. From the above table, what zone would a public server be in? Public server should be in the DMZ zone, demilitarized zone. From the above table, what zone would a core domain controller be placed in? It is the restricted zone. So here it is kind of, or it is similar to an internal server, a server that's only dedicated to be used internally, okay, such as active domain controller installed Active Directory installed on domain controller Windows Server. This is an internal server. Now, why don't we place these servers, okay, also on the internal network? If we place these servers, web servers, such as a web server, email server, or proxy server, or other servers on the internal zone, what's going to happen here is if these servers got attacked, the infection will spread easily to the user workstations, which means we will jeopardize the sensitive information stored on these workstations. So what do? We place these servers on a separate zone. We connect them to a different port on the firewall, and we connect the internal zone devices on another different port on the firewall. Okay, so that when we can create packet filtering rules and access control lists on the firewall, we'll be able to dedicate rules for the DMZ that are different from the rules dedicated for the workstations, so that we control the packet flow efficiently from the internet. For example, if a user wants to connect to our network, okay, on port 80, we're gonna forward the request to the web server here, not to the workstation. Okay, so network security policies and controls. Here we introduce the concept of access control lists and traffic filtering. So explain that here as well. So firewall, we will write the access control list on the firewalls, on the firewall. So access control lists are rules we write or we specify on the firewall or even on the router to control the traffic flow. Access control lists accept, deny, or deny or accept. So we can specify the action of the access control list as deny or accept. So we can either accept the packet or deny it based on the source and source and destination IP addresses, sometimes source and destination ports. And ACLs are heavily discussed in Security Plus certification. As you can see, this is an example of access control list. So its name is 1. Rule number 1, the action is to permit based on the source IP address. So if there is traffic coming from the source IP address, we're going to permit the packet. Another example here where the action is deny, the source is this IP address. So all packets coming from this IP address, we're going to deny them. Now, access control lists can be used in stateless firewalls. Stateless firewalls are firewalls that can only control the packet flow based on the source and destination IP or port. They cannot track the state of the connection. That's why we call them stateless. And ACLs used in both stateless and stateful firewalls. So these questions here are very easy to answer. According to the corresponding ACL policy, will the first packet result in a drop or accept? That's the first packet here. As you can see, it's IPv4, the source coming from this IP, and that's where the packet will go, destination IP. And so according to the access control list set on the firewall, the action is to permit the traffic coming from this network. So since this IP address here lies on this network, we're gonna permit the traffic. So the action is to accept. According to the corresponding ACL policy, will the second packet result in a drop or accept? This is the second packet. And based on the access control list, we deny all the packets that are destined to this IP address. So this IP address is in the destination, that's why we're gonna deny the packet. So that's the job of the ACL, and remember the ACLs are written in the firewall. We use the ACLs to control the packet direction based on the zones. Zone pair policies and filtering. Alright, so here we have a static site. Let's go ahead. Alright, so we have, as you can see guys, a network that is, as you can see, divided into VLANs. We have the LAN, not VLAN, security zones, let me call it. The LAN zone, the DMZ zone, and the WAN zone. and we have a firewall, and here we are writing policies to control the packet flow. So the example here takes the direction coming from DMZ to LAN. They are changing, as you can see. We have to reset this. So here the example or the scenario is packets from DMZ to WAN. I'm gonna need to refresh this because if they keep changing, I'm not gonna be able to do the challenge. So going back, view site. Our job here is to write the access control lists. So here we have DMZ to LAN. So we're gonna set the policy, set zone policy, zone, click on that, and we select DMZ. The default action according to the table is to drop. We're gonna drop, and we're gonna set the interface to which DMZ is connected. DMZ is connected to interface Ethernet 0.10, 0.10, 0.10, and the other one will be on LAN. So LAN default action will be drop. LAN is connected to interface 0.20. Now we set the firewall rules here. Okay, the firewall rules, if we are talking about DMZ to LAN, so set firewall rule name here, DMZ to LAN. DMZ to LAN, description DMZ to LAN. The firewall rule name here also DMZ to LAN. And the default action, we're going to take a look at the security policy here. So this is a security policy set by your team to control how the traffic will flow. So from DMZ to LAN, the default action is to drop. So we're going to drop the packets, and then we're going to specify what is permitted. So again, DMZ to LAN. The rule action here is to accept packets on the HTTP protocol. Accept the protocol here will be HTTP, and it's DMZ to LAN. Run, and it works. So here from DMZ to LAN, meaning if you go back to the diagram here, from DMZ to LAN meaning from the web server or email server to the workstations. So what does that mean? It means if a user from the internal network, okay, requested a resource or requested a web page on the web server, they need to communicate with the DMZ zone. Meaning when the web server wants to send a response back to the client, the packet direction will be from DMZ to LAN. So we're gonna have to allow this, and that's how we allow this here. Let's take another example. It's from DMZ to WAN right now, meaning from the server's zone into the internet. So now let's go ahead and do it. So DMZ to set zone policy, DMZ, default action will be drop, and here DMZ we're gonna set the interface to 0.10. Then we set 1 on the other side. Default action is to drop, and 1 is connected to the interface 0.30. Now let's set the firewall policy here. So the firewall policy will be from DMZ to WAN. Okay, description DMZ to WAN, and the firewall rule name will be again DMZ to WAN. Default action will be to DMZ to WAN here to drop. It's going to drop. Firewall rule name DMZ to WAN again. The rule action here, there is no rule action for DMZ to WAN. Also here DMZ to WAN. So nothing is set here. Gonna run, not gonna work. Gonna drop. If we drop, say ICMP, yeah. So WAN, the default action is to drop. WAN is on 0.30. DMZ to WAN. Okay. DMZ to WAN. Default action is to drop. Yeah. So here it didn't work because the challenge was set to from DMZ to LAN here. I don't know how to change this, but anyway. So we did this for DMZ to, I guess, to LAN, right? All right. Going to the next challenge or the next task. Validating network traffic. So let's talk about SSL inspection. So let's go back to the example. Let's say the web server was operating a website and you have an SSL certificate, right? So all the packets coming from the internet to the web server on the HTTPS protocol, or if they are encrypted, your firewall will not be able to inspect the contents. That's why you need something called the SSL inspection. And this is achieved through something called the Unified Threat Management. Unified Threat Management is a platform that combines many security features, including IPS, also SSL inspection is within these features. Addressing common attacks. So DHCP snooping and dynamic ARP inspection. DHCP snooping is a security feature that prevents a DHCP server or a rogue DHCP server from allocating IP addresses. ARP inspection here is also a feature that addresses the ARP protocol and make sure that no malicious ARP packets are sent in the network. These questions are easy to answer. So where does DHCP snooping store leased IP addresses from untrusted hosts? It's the DHCP binding database because they work closely. Will a switch drop or accept DHCP release? It's gonna drop. And does dynamic ARP inspection use the DHCP binding database? Yes. Dynamic ARP inspection will match an IP address and what other packet? MAC address. So if the IP doesn't match the MAC address, the ARP inspection will drop the packet. So that was for this task or for this room. Now most of these concepts are discussed very heavily in the CompTIA Security Plus, which I would like to give you good news, guys. I'm preparing a dedicated CompTIA Security Plus notes guide. I started the preparation of this guide and soon it will be released. If you are subscribed to this channel membership, you will be able to access this notes guide when it is released. When it is released. I stress this line, guys, because if you have subscribed, you're gonna be asking me, I don't see this note file in the Google Drive or in the portal. Yes, it's not released yet. I'm just telling you guys it's gonna be released maybe in 2 weeks. So stay tuned.